Hello. So in our last video, I gave you this kind of fun problem where you had this rectangle, and I gave you a couple pieces of information. And the pieces of information I gave you are those in green, so 30 degrees, root 3, 1, and 90 degrees. Then you had to come up with all the other information in this diagram. And what I said was that this diagram is useful because it actually tells you what your special triangles are, and it gives you all their primary trig ratios. So this is a nice diagram you can quickly sketch out, and you can always pull your primary trig ratios from it for your special triangles. So now let's actually look at what the special triangles are that are inside of this. This diagram actually gives you 3 special triangles, but we're really only interested in 2. But we'll do all 3 just for the sake of this video. So the first one that we have is this 30, 60, 90 triangle, and that's your first special triangle. So our first special triangle, let's change our color here, is 30, 60, 90 triangle. So in this case, opposite of the 30 is 1, adjacent to the 30 is root 3, and the hypotenuse is 2. So this is your first special triangle. Now, in a number of my other videos, what I've said is that it's important to memorize sine of 30 is 1/2, and you can see that in this diagram. So sine of 30 degrees is 1/2. But now I can also give you cos of 30 degrees, and that's going to be root 3/2. And I can give you tan of 30 degrees, which is going to be 1/√3. And not only can you get the primary trig ratios for sine 30, cos 30 degrees, and tan 30 degrees, you can also do it for 60 degrees. So sine of 60 degrees is equal to, well, root 3/2. Let's scroll this up just a little bit here. There we go. Cos of 60 degrees is equal to 1/2, and tan of 60 degrees is equal to root 3/1, which is often just written as root 3. So whenever you're working through a problem that involves some trigonometry, and specifically sine, cos, or tan of 30 degrees or 60 degrees, you want to use these exact values, not the approximate values that you get in some cases. You know, for example, sine of 30 you might get 0.5, but I do recommend you get in the habit of putting 1/2. Remember, fractions are a friend, and they're going to actually help you simplify a lot of your work later on. So this is your first special triangle of 30, 60, 90, which can be pulled from this part of the diagram, or it can be pulled from this part of the diagram. The second special triangle in here is a 45, 45, 90. So we try and draw, this is just a sketch here, so that doesn't look very good. Let's try this again. So this is a 45-degree angle, this is a 45-degree angle, and we see from this it has the lengths 2, 2, 2 root 2. Now, what you can do here is remember, sine, cos, and tan are ratios, right? So it doesn't matter that the lengths of the sides, the ratio is always going to reduce to the simplest form. So if we have 2, 2, and 2 root 2, we can actually simplify this to 1, 1 root 2. And so we can actually write the ratio using either 2, 2, 2 root 2, or we can write the ratios using 1, 1 root 2. So let's actually write out the ratios using this simplified version of the triangle. So we see that sine 45 degrees is equal to 1/√2. We see that cos of 45 degrees is equal to, well, it's the same thing, 1/√2. So that's an important thing to note, that sine of 45 degrees and cos of 45 degrees is the same. And we see that tan of 45 degrees is equal to 1 over 1, which is 1. Now remember, it doesn't matter if you take the sine, cos, or tan ratio using either 2, 2, 2 root 2, or 1, 1 root 2. You're going to reduce the same thing. One mathematical habit that we like to develop is called rationalizing the denominator. So many people will write sine 45 degrees. I'll just write it again here. We'll actually come over a little bit this way. Sine of 45 degrees. They'll actually write it out as they'll use, well, two ways they'll get this. They'll either say, actually no, let me go back a second. What they're going to do is they're going to rationalize the denominator. They're going to multiply both the denominator and the numerator by root 2. So they're going to get root 2 over 2. They'll say cos of 45. So again, if I have 1 over root 2, I want to get that root 2 out of the denominator. So I'm going to multiply the denominator by root 2, which is going to give me 2. But if I multiply the denominator by root 2, I can multiply the numerator. So I get root 2 over 2. And again, tan of 45, well, that's still going to give us 1. Okay. So again, when you're working with a problem and you have sine, cos, or tan of 45 degrees, we want to be using these exact values now. So let's talk about why I use this diagram. Now, I'll be honest, there are easy ways to remember the 30, 60, 90 ratios and the 45, 45, 90 ratios. And I will have a video with a couple of those techniques, and you got to use a technique that works for you. What I really like about this diagram is it gives you a bonus special triangle, the 15, 75, 90. And there's a good chance that this won't show up in much of your work if you're working at the level that I'm teaching at, which is grade 10, 11 math. However, that being said, it doesn't mean it's not good to know, and it might come up in a more challenging question. It's always fun to throw some curveballs, right? So in our last special diagram is the 15 degree, 75 degree, 90 case. So in this case, notice again the difference here is that as opposed to being a nice number, it's across 15 degrees is opposite of root 3 minus 1. And then we have 1 plus root 3, and then we have 2 root 2. So now we can say sine of 15 degrees is going to be root 3 minus 1 over 2 root 2. Cos of 15 degrees is going to be 1 plus root 3 over 2 root 2. Tan of 15 degrees is going to be root 3 minus 1 over 1 plus root 3. And now we can do the same thing for 75 degrees. So sine of 75 degrees is equal to 1 plus root 3 over 2 root 2. Cos of 75 degrees is equal to root 3 minus 1 over 2 root 2, and tan of 75 degrees is equal to 1 plus root 3, that's the opposite, over root 3 minus 1. Be careful not to cancel those root 3's, because there's an addition sign or subtraction sign between them. So these are your special triangles. Again, I'm sure if you've actually sat through this full 9 minutes of this video and you're watching, good on you, because I think a lot of people might have turned it off by now, because it is pretty dry stuff as I write all these out, and you can get it pretty quickly. But I do want to stress that anytime you're taking the sine, cos, or tan of any of these angles now, you want to be using exact values. This is going to be really useful in a number of cases, because sometimes with harder problems it will cause things to cancel out in your math just to filter out nicely. Anyways, in our next video I'm going to show you a different way to memorize these, so you don't have to draw this diagram every time. But it's not that hard to draw once you get it, and yeah, I think it's kind of fun. Have a great day.